Root test. The question are using root test determines whether the following series converges or diverges. The following series converges or diverges. Another name for a root test is end-the-root test. It states that if this is your series an, then the root test is limit as n approaches infinity, the nth root of an is equals to low. So if your low is less than 1, it automatically converges. And if your low is greater than 1, it diverges. If your low is 1, then the series is inconclusive or inappropriate. So we check for example 1 and example 2. Question 1. Use the root test to determine the convergence or divergence of this series. And we have said that the root test states that limit as n approaches infinity, the nth root of an is equals to low. So your an is equals to 3n divided by 4 to the power n. So limit n approaches infinity, n root of 3n and the root of 3 raised to the power n divided by 4n, which is equals to limit n approaches infinity, 3 raised to the power n over 4 raised to the power n, 3 raised to the power 1 over n. So 3 raised to the power n times 1 over n. So n multiplied by 1 over n, it will be 3. 4 raised to n times 1 over n, it will be 4. So your answer is 3 over 4, which is less than 1. And this converges by root test. It converges by root test. Example 2, the series is n minus 4 raised to the power n divided by n, and we determine whether this series converges or diverges using root tests. We have said that a root test states that limit as n approaches infinity, an, you find the nth root. So this is direct. Limit n approaches infinity, your an is n minus 4 raised to the power n divided by n. You find the nth root of this. So n minus 4 is the power n. This n and this cancel. So your limit will be limit n approaches infinity, n minus 4 over n. So you equate for n to be infinity. You have infinity over infinity. This is non-determinate. You make it to be determinate by using L'Hospital's rule, which implies that you differentiate numerator and denominator separately. So limit as n approaches infinity, you differentiate numerator, it will be 1, denominator will be 1, automatically your limit is equals to 1. So the is 1, and we have said that if you find that your low is 1, it implies that the series is inconclusive by nth root test. So you say that the nth root test is inconclusive or inappropriate.